Okay, so the next topic I want to cover is I want to cover one question on L'Hopital's rule, and the question is given by limit as x approaches infinity, e to the 3 over x minus 1 all divided by 3 over x. Now, as you know, in L'Hopital's, we have certain restrictions. We use L'Hopital's to calculate limits, but with certain restrictions. If we are calculating the limit and your answer is coming in the 0 by 0 form or infinity by infinity form or 1 to the infinity form or so on, these are called indeterminate forms. So while calculating the limit, if you encounter any of these forms, you are more than welcome to use L'Hopital's. I mean, you can do your limits analytically, graphically, or numerically. L'Hopital's is just another way to calculate limits. Sometimes it's much easier to use L'Hopital's as compared to any other method. So let's look at this example, which is limit x approaches infinity, e to the 3x minus 1 over 3x. Now, as x approaches infinity, if x approaches infinity, let's see where this guy approaches 3 over x. So as x approaches infinity, if you all agree with me that 3 over x approaches 0, this is just the reciprocal function, just stretched version. 3 over 3 is a constant. So as x approaches infinity, your function approaches 0. It's going down and down, it's decreasing, and it's getting to 0. So this part goes to 0, and similarly 3 over x here goes to 0. So overall e to the 0 is 1. So overall what's happening is overall this function is going to 0 by 0 form. So very good. We can use L'Hopital's. Now what L'Hopital says is if you have a function, let's say f of x by g of x, and you evaluate the limit as x approaches to any number a or infinity or negative infinity, and you are getting an indeterminate form. So let's say you are getting a 0 by 0 form. So what L'Hopital says is then this limit, the same limit as x approaches a of f of x by g of x, is same as limit as x approaches a of the derivative f prime of x by g prime of x. And not just this, again, if it is a 0 by 0 form, you can continue this on to the second derivative and so on, which is same as f prime of x divided by g prime of x and so on. Now, a point to note here is this is not quotient rule. Whenever we have f of x by g of x and you want to take the derivative, you use quotient rule. But this is taking the derivative of the numerator and denominator separately. So a lot of students, if you I can tell you that a lot of students actually use quotient rule like this. This is not quotient rule. This is just the taking the derivative of the numerator and denominator separately. It's easier than quotient rule actually. So let's apply this to my function, which is limit, since I'm getting a 0 by 0 form. So limit as x approaches infinity e to the 3x minus 1 over 3x. Let's take the derivative of the numerator. Since the derivative of e to the x is e to the x, so e to the 3x will be e to the 3x. But 3 over x is not x, it's a function of x. So by chain rule, I must multiply with the derivative of 3 to the x minus the derivative of 1, which is a constant, is 0, all divided by again the derivative of 3 to the x, right? If you want, you can actually calculate the derivative or just leave it like that in this particular question, because my 3 to the x and 3 to the x will cancel out. So I can actually cancel, I wanted to use another color, so I can actually cancel this and this. These are the same. So what I'm left with is, and limit is floating around everywhere, which what I'm left is limit x approaches infinity of e to the 3x. Now I know as x approaches infinity, 3 to the x goes to 0, which is same as e to the 0, so which is 1. Right? So this was one of the questions which was asked by a student. So hopefully this helps, and let me know if you have any other question. Take care.